Okay, so now let us discuss about what are parallel lines. And when you start off, I want to first tell what do parallel lines mean. I'm sure that you have discussed about parallel lines and geometry in your 6th standard and you figure out what parallel lines are, but I'm just going to reiterate what parallel lines are. So two lines are supposed to be parallel. So let me just write it down here. Two lines are supposed to be parallel if there are two conditions satisfied. Parallel if one, they are in the same plane. I'll explain to you what this means. Let me first write it down, the 2 points. The second point is they do not intersect. They do not intersect however far they are extended. Yeah, I think probably you need a little bit of explanation of what this means. So first thing is they are in the same plane. What does that mean? They are in the same plane. What does that mean? What is a plane? Right? Now let us look at this notebook. Now this is actually a plane. Why? Because it is one single surface. So which is defining a plane. Right? Now if you look at this tabletop, which is here, this is a different plane on which this book has been kept. So this is a different plane. Right? So what you're talking about is two lines which is in the same plane. So I cannot talk about one line which is on this notebook and other line which is on this tabletop, right? Which is on this tabletop. That's not acceptable, right? So both should be in the same plane. So when you're talking about two lines, you can talk about two lines which is on this notebook or two lines which is on this tabletop. That is fine because you are talking about two lines which is on the same plane. So I hope you understood what that means. So first thing is that the parallel lines, two lines should be on the same plane. That's one thing, right? And the other thing is that they don't intersect. Now what do you mean by intersection? Right? Now if I draw two lines like this, I know that you have already learned what is intersection, but just to explain, so let me take the... So let's see that I draw two lines like this, right? So, right, I have one line here like that and the other line is like this. Now these two lines are intersecting. It is intersecting at a point O, right? So both the lines are intersecting. Do you agree with me? Absolutely, right? So these two lines are intersecting. Now let us take another scenario where I'm going to draw two parallel lines, right? So I'm drawing a line here first. So here is one line. So here's one line. I define this line as A, B, right? And I'm going to draw a parallel line, a line which is parallel to this line, right? So now, as you know, I can draw lines using two set squares which are parallel. So I've made this set square aligned with this line and I'm going to draw a parallel line. So here we go. So this is a parallel line, right? So I've drawn another line CD, which is parallel to AB. Now the interesting fact of this line is the distance between these two lines, these two lines will never intersect to each other. Never. Right? So never it will intersect with each other. So I keep on prolonging this line in these ways. That means I extend this line this way or I extend this. So I decide to extend this line this way and extend this line this way. I extend it to whichever distance possible on this plane. It will never intersect each other. And same way, I can decide to extend it this way and extend this line this way. I extend it whichever amount of distance on this way, right? This way or this way. In both these cases, it never intersects, even if I take it to 100,000 kilometers away, it will still remain parallel, right? So the parallel lines are those lines, two lines which are on the same plane and which will never intersect, however much you are extending those lines in either directions, right? So that is what does parallel line mean. And I using two set squares, I can draw parallel lines. So if I draw a line, then I can draw a parallel line to that specific line, any number of parallel lines to that specific line using set square. Let me show you that, right? So I know you might have learned it before, but I'm just going to explain that again, how I can draw parallel lines. So let me draw a line here. So here is a line, right? And I name it AB, right? So that's line AB, and I want to draw parallel lines to this line. I want to draw maybe 3 parallel lines, assume. So what I can do is I can first align the set square this way, exactly along that line, and then just put the other set square along one of the sides and just slide it like this, right? Now, and then I can draw one line here, right? Then I can draw another line here, and all these lines will be parallel to the line AB, right? Another line here, and so on. So I can draw any number of, so all these lines, C, D, E, F, G, H, all these lines are parallel to the line AB, right? And however much you extend these lines on either directions, it will never intersect with line AB. So the line GH, line CD, line EF, line CD, line EF, line GH, none of this will intersect with line AB, however you extend it on both the directions. So this is basically what parallel lines mean, and this is how I can draw parallel lines using the two set squares, right? Now, keeping that in mind, I'm now going to start speaking about some of the properties of parallel lines, right? So that's what I'm going to talk about. So let me again draw 2 parallel lines, right? So I'm going to draw 2 parallel lines again. So this is AB, right? And I'm going to draw a parallel line to AB, which we'll call CD. So this is the parallel line CD, right? Now, what I can do is I can draw a line which cuts both these lines at distinct points, which is called a transversal line. So this is a transversal line which I'm drawing, right? So this is a transversal line. I'll say it is EF, right? So this is basically called a transversal line. Transversal line, right? That's what it's called, a transversal line. So if you look at this particular line, probably I think so I explained what a transversal line is. I'm actually going to shift back to Wacom to continue my explanation, because that will be far more clearer. So I think you've understood how to draw parallel lines and what a transversal line means, right? Now we will actually get into the different angles that we'll come across in the case of this kind of lines. So let me just alright, so let me just get into that. Okay, alright, so let us look at 2 parallel lines. So here we have just Okay, so let us just do that. Okay, so now let us look at this specific diagram, and let me just continue with that. And let me mark these angles using a sketch pen to make it more visible. Right? So I actually have these angles, angle 1 and angle 2 and angle 3, angle 4. I'm just marking all this so that's very clear to you, right? And here I have angle 5, angle 6, angle 7 and angle 8. Right? Now, what are so much special about all these angles, right? And I want to define what are some of the so if you look at the angles 1, 5, angle 2, 6, right? So let me write, so what you call the corresponding angles, right? So corresponding angles. Now the corresponding angles are angle 1, 5, right? Angle 1 and 5, angle 1, 5, angle 2, 6, right? Angle 2 and angle 6, right? And angle 3 and 7, angle 3, 7, right? Angle 3, angle 7, right? And angle 4 and angle 8, 4 and angle 8. All these are called the corresponding angles, right? I don't know whether you're getting a better view of it. Probably I'll move the camera more near. I think now it's clear, right? Camera a little more, make it a bit upish now. Okay, so now I think it's clear, right? So corresponding angles are angle 1, 5, which is angle 1, 5, angle 2, 6, which is angle 2, 6, angle 3, 7, 3, 7, and angle 4, 8, 4, 8. Now the fact of the matter is, all these corresponding angles will be equal to each other, right? Now let us look at that. Is that really true? Right? Is that really true? So mathematicians should always be having a challenging mind. So 1, 5, let us look at 1, 5, right? So angle 1 is 60, probably 61 degree, right? Let us look at angle 5. You can see that angle 5 is also 61 degree, right? Now let us look at angle 2, 6. So angle 2, 6, is that really right? It is around 119 probably. It's around 119 because these two angles should definitely sum up to 180, right? Because this is, both these angles are adjacent angles on the same side of the line, and you would have remembered the theorem which you had learned in lines and angles, where you say that the the total angle on one side of a line is 180 degrees. So the sum of these two angles should be 180 because they are supplementary angles, right? And so and you can see that here also it is 119 degree, right? So you can see, you can try it out yourself and you can see that all these angles will be the same. Okay, so that is corresponding angles. Then there's something else, alternate interior angles, right? Let's look at what is alternate interior angles. Alternate interior angles. Now which are alternate interior angles, right? So I think probably I'll just write it here so that it's more clear, right? So let me write it here. So corresponding angles are angle 1, and angle 5, right? Angle 2 and angle 6, right? And angle 1 and angle 2 and angle 6, angle 4 and angle 8, angle 3 and angle 7, angle 3 and angle 7, and angle 4 and angle 8, right? So they are the, so since the diagram is clear here, I would rather thought that I would write it here so that it's more clear. Now, what are alternate interior angles, right? Now, what are alternate interior angles? So alternate interior angles, alternate interior angle. Let's look at alternate interior angle. So the alternate interior angle is angle 3 and angle 5. See, they're alternate angles. On two sides they come, right? So angle 3 and angle 5. Angle 3 and angle 5. So they are alternate angles because on the two sides of the line, right? So angle 3, angle, angle 3 and angle 5 is alternate interior angles. Angle 4 and angle 6 is also alternate interior angles. Angle 4, angle 6, alternate interior angles. They are alternate on the two sides of it, right? So angle 4, angle 6. Now, corresponding angles, as I told you, are equal. So angle 1 is equal to angle 5 and so on, right? Now you can see that the alternate interior angles also are equal. Angle 3 is equal to angle 5, and you can see that, right? I can measure it. So let us look at angle 3. So angle 3 is coming to 62, right? 62 or 61 probably. Yeah, angle 1 is 61, so angle 3 also should be 61 because they are opposite angles, right? And here you can see that even angle 5 is 61, right? So both the angles are 61. So you can see that they are the same, right? Now I will also try to explain it and prove it, right? I will do that after I finish all this. I want to do that. Now, what is the alternate exterior angles? Now, what are alternate exterior angles? Alternate exterior angles are angle 2 and angle 8, right? So alternate exterior angles, angle 2 and angle 8, and angle 1 and angle 7, sorry, angle 1 and angle 7. They are alternate exterior angles. So let us look at that, right? So alternate exterior angle. Angles are angle 2 and angle 8, angle 2, angle 2 and angle 8, right? And angle 1 and angle 7, angle 1 and angle 7. So they are alternate exterior angles. Now you can see that the alternate exterior angles are also equal to each other. So angle 4 is equal to angle 6. Similarly here, angle 2 is equal to angle 8 and angle 1 is equal to angle 7. Right? Now let me just measure it. Angle 1 is again 61 degree, and you can see that angle 7 will also be 61 degree. 61 degree. Right? Now let us do some math here and try to prove all this. Right? Let us do some math here. Right? Now let me call, do I have some other color? Okay, let me use the blue ink probably. Okay. Now let me say that this angle is x. Let me say that this angle is x. Now what can you talk about this angle? Angle 2. It is definitely going to be 180 minus x. Why? Because these two are angles which are on the same side of the line, and they are adjacent angles and supplementary angles. So definitely angle 2 should be 180 minus x. Do you agree with me? So if this is x, this should be 180 minus x, right? Should I use the same? I think it's better. 180 minus x if this is x, right? So if this is x, this should be 180 minus x. Alright, so in which case these 2 and 4 are opposite angles, and so this should be 180 minus x. Do you agree with me? Yes. And this should be x, because these are opposite angles. So this is clear. Now comes the interesting fact of parallel lines. Now the thing is, these two lines are parallel to each other, right? And since these two lines are parallel to each other, and this line is one single line cutting both the lines, the angle, this angle 1, what you see here, is based on the orientation of the two lines, right? The orientation of two lines. Since both these lines are parallel to each other, this line and this line are in the same orientation. Because of that, this angle 5, which is corresponding to the angle 1, should be the same measure. So that means this should be x. Why? Because both these lines have the same orientation, because on this plane, right? Because they are parallel, and hence this angle should be equal to this angle. It just can't be the other way. But whereas, let me explain. Now assume that this line is not parallel, right? Now let me draw a line like this. Let me draw another line like this, right? Just to prove the fact. Now you should also remember that when I measured using the protractor, I really found that these two angles are the same, right? And why are they the same? Now here we go. Here you are drawing another line, right? Now this is another line, and I call this B dashed A dashed, right? B dashed A dashed. Now what can you say about this line? What can you talk about this line? This line is not parallel. Why? Because if I extend it a little more, I am sure that these two lines are going to intersect. Correct? And you can see that since these two are not parallel, their orientation is different. This is oriented this way, but this is oriented this way. The orientation are not the same. And because the orientation are not the same, this angle and this angle will not be the same. They are not going to be corresponding angles. So you can see that, right? If I measure angle B dash, let's say this is called O, B dash O P, right? This is P and this is O, the intersection point. B dash O P, this angle is now 93 degree, whereas this angle DP or F, right? This angle is 61 degree. So why is that happening? Is because this line is not oriented the same way as this line. So these two lines are not parallel. So when two lines are parallel, the orientation of both the lines is the same. So here, if you look at A, B and CD, their orientation is the same. And since their orientation is the same, they will intersect this line EF with the same angle. And that is why angle 1 and angle 5 are the same. You understood? So that means if assume the angle 1 is x, angle 5 is going to be x. And if angle 5 is x, then angle 6 is going to be 180 minus x. And angle 8 is also going to be 180 because they are opposite lines. And 7 is going to be again x. I am getting all the stuff correct. So we are saying that angle 1 and 5 are the same. That's true. Angle 1 and 5 are x and x. Angle 2 and 6 are the same. Angle 2 is 180 minus x. Angle 6 is 180 minus x, which is also correct. 3 and 7 are the same. 3 is x and 7 is x, right? Angle 4 and 8 are the same. Angle 4 is 180 minus x, and angle 8 is 180 minus x. Now let us look at the alternate interior angles. So we're talking about angle 3. Right, angle 3 is equal to 5, right? So let us look at angle 3 is equal to 5. So angle 3 equal to 5. So is angle 3 equal to 5? You can see angle 3 is x and angle 5 is x. right? Now let us look at angle 4 is equal to 6. Angle 4 is equal to 6, right? So that is the next one. So angle 4 is equal to 6. So let us look at that. Angle 4 is equal to 6. Is angle 4 equal to 6? Angle 4 is 180 minus x and angle 6 is 180 minus x. So they are equal, right? Then alternate exterior angles. So angle 2 is equal to angle 8. So let us look at that. Angle 2 is equal to angle 8. So angle 2 is 180 minus x and angle 8 is 180 minus x. So they are equal, right? And let's look at angle 1 and 7. Angle 1 and 7. Angle 1 and 7. Angle 1 is x, angle 7 x. I want you to please draw parallel lines and check it out yourself. This is what will consolidate the concept. Don't try to mug things. That doesn't make any sense. Don't try to by heart is a wrong word to use in mathematics. No by heart. Everything is because everything is logic. As far as you know the logic, everything else can be derived, right? So please try to derive it yourself. Draw two parallel lines, draw the transverse line, and then try to get all the angles and try to see how it works. Now there is one more concept which is there we need to think about, right? And that is the consecutive interior angles. Consecutive interior angles. Let me just look at that. Consecutive interior angles. So what about consecutive interior angles? Now what about that, right? So let us look at that. So here the consecutive interior angles is angle 3 and angle 6. Angle 3 and angle 6 are consecutive interior angles, right? Angle 3, angle 6 are consecutive interior angles, these two. And also angle 4 and angle 5 are consecutive interior angles. And the interesting part of this is angle 3 plus angle 6 will be equal to 180 degree. And similarly angle 4 plus angle 5 is going to be equal to 180 degree. Right? So angle 4 plus angle 5, angle 4 plus angle 5, these are two consecutive interior angles, and angle 3 plus angle 6, these are also two consecutive interior angles, and the sum of those two angles are going to be 180 degree. Now let us try to see whether that is true. Yes, it is, because angle 4 is 180 minus x and angle 5 is x. 180 minus x plus x is 180. Similarly, angle 3 is x and angle 6 is 180 minus x. So x plus 180 minus x is again 180. So you can see that that is true. The consecutive interior angles is definitely, the sum of them will be 180 degree. So these are four important rules that you have to think about parallel lines, and once you think about this, there are a lot of interesting things that you can derive out of that, right? And that is where we'll just step into a few problems, right? So let us just try to do a few problems. Let me just try to see whether I can. All right, so okay, fine. So let us just try out a few problems now, right? So let us again try to do this. So first, let me draw this. Oops. Okay, let me just try to draw two lines. Okay, back to pen. All right, now so let us consider that there are two parallel lines. So this is parallel line L, and this is parallel M, right? So there are two lines L and M which are parallel to each other, and I have a transverse line. So this is a transverse line, right? T, right? And the angles, this is angle 1, 2, 3, and 4, and this is angle 5, 6, 7, and 8. Alright, now what is given? What is given is this, right? It is given that angle 1 is to angle 8, angle 2 is equal to 5:7. That's what's given, right? Angle 1 is to angle 5 is 1:7, right? Let us just make this, yeah. So this is what's given. Angle 1 is to angle 2 is 5:7, and what is asked is find all the other angles. So I want all the other angles we have to find, right? That's basically what is told. Now what can you do, right? Now since you are given the angle 1 is to angle 5, angle 1 is to 2 is 5:7, there's something that you can say. Now let us assume angle 1 is x, right? So angle 1 is, let us assume angle 1 is x, right? So which basically means angle 1 equal to x, which also means angle 2 is equal to 180 minus x, because they are supplementary angles, right? They are supplementary angles. So now we can say that the ratio of these two angles is given. So x by 180 minus x is equal to 5/7, because that's given. The ratio between the two angles are given, right? So which basically means, now what I can do is I can use the principle of equality and multiply both sides by 180 minus x. So I get it as x equal to 5/7 into 180 minus x, something that you have already discussed in the linear equations. If you didn't understand how I have written this, please go through my linear equations, a single variable linear equations videos. It very clearly explains how we do that. And then this 7 I want to remove from the denominator, so I multiply both sides by 7, so it becomes 7x equal to 5 into 180 minus x, which basically means 5 into 180 minus 5x, right, is 7x, and then I can take this 5x on this side, transposition, so it becomes 12x equal to 5 into 180, and which gives me x equal to 5 into 180, and of course I divide both sides by 12, right, and so then I can cut this, I make it 6, and this makes 30, then I can cut the 2 against 30 and make it 15, so which basically means x is 75, right? So x is 75 means, so that is angle 1 is 75, and if angle 1 is 75, then what is angle 2? Angle 2 is 180 minus 75, which is nothing but 105, right? So angle 1 is 75, angle 2 is 105, and so which basically means angle 3 is 75, right? And angle 4 is 105, because they are opposite angles, right? Now what about angle 5? They are corresponding angle to 1, so which means angle 5 is 75, and if I know that 75, then I can use the same rules, right? So angle 6 is again supplementary to angle 5, so angle 6 is nothing but 105, and since angle 6 is 105, angle 8 is opposite to angle 6, right? So that is also 105. Angle 7 is opposite to angle 5. So angle 7 is 175. All the angles I got. Pretty simple, right? So this is the way I can actually do this problem. Very straightforward. You agree with me? Yeah, so this is question 1. Now, so did you understand? So very simple. I just have to use this linear equation. So this is a linear equation. Which I formed using this particular fact which is given in the question. Using this fact which is given in the question, I got this linear equation, right? And as soon as I got the linear equation, I got the two angles. And once I get the two angles, using the concept of supplementary angles, opposite angles, and alternate interior angles, and all that stuff, I will be able to kind of get all the other angles, right? So that's what I did. All right, now let us look at next problem. Question number 2. Right, so now here, so two parallel lines, right? So two parallel lines. So this is L and this is M. Two parallel lines, right? And it is cut by a transverse line T. So this is T, right? And if the interior angles of the same side, right? So the interior angles. So what are the consecutive interior angles? So here these are the consecutive interior angles. The interior angles of the same side are, right? So the first one is 2x minus 8 degree, 2x minus 8 degree, and the other one is 3x minus 7 degree. Find the angles. Find all the angles, right? Now what I can do, now these are consecutive interior angles, and so the sum of the consecutive interior angles should be 180 degree, right? So since the sum of consecutive interior angles should be 180 degree, right? And hence we say 2x minus 8 plus 3x 2x minus 8 plus 3x minus 7 is equal to 180 degree, right? Which basically means 5x minus 15, right? I've just summed it up, is equal to 180, which means 5x equal to 180 transposition plus 15, which is nothing but 195, which gives me x equal to 37 degree. X is 37 degree, and if x is 37 degree, that means what is this angle, right? So 2x minus 8 will be equal to 2 into 37 minus 8, which is 74, right? Yeah, 74 minus 8, which is 60. 74 minus 8 is 66 degree, right? And what will be 3x minus 7? 3x minus 7 will be 3 into 37 minus 7. 37 into 3 is 101, right? 101 minus 7, 101 minus 7 will be 104 degree, right? So 104 plus, no, 104 minus 104 plus 66, something wrong. 74 minus 8 is 66, because sum of these two should be, let me see, 37 3s are 100 the 1 2 101 minus 7 is 104. 66 will only be 170. There's something wrong. 2 into 30. Let me see. 30, 50. Oh, this is 39. Sorry. Small mistake. 39. This is 39. 39 means 12, 18, 1. That is 78. So, which basically means this is 70 degrees. Small careless mistake. I'm sorry for that. So, this is 70 degree, right? And this is again 39. And so which gives me 117, which makes it 110. So this would be 110 degree, right? So, and if I sum this up, 110 plus 70 is 180. And if I have this equal to, so that means this is 70 degree and this is so probably the line should be a little bit on the other side, right? So I've got these two angles now, and if I get these two angles, then I can get all the other angles. So this is 70 degree, right? And this is actually what? How much is this? Is 110 degree, right? And so this will become 110 degree, and this becomes 70 degree, and this becomes 70 degree, and if this is 70, this becomes 110. And this becomes 110. That's it. All the angles known, right? So just use supplementary angle stuff and you're done. So that's it. Pretty straightforward problem. Don't you think so? Okay. Now let us look at this one. Question number 3. Now here we have a triangle. So this is a triangle. This is a triangle, right? And let's call this A, B, C, and then there is a line here, DE, line DE, and this line DE is parallel to, this is symbol for parallel to, right? Parallel to, this is symbol used in geometry, parallel to BC. Right, so line D is parallel to BC. All right. Now, it is given that this angle is 65 degree, this angle is 45 degree. Now, what I have to find is what does the angle? Now, this is Y and this is X, and we have to find what is X equal to what and Y equal to what. That's the question. All right. Now, how will you do this? Pretty straightforward. Now, what is the sum of the angles of a triangle? Sum of all, that's also not required. Maybe you've not learned that yet. Okay, wait. So, let's not bother about that. Okay. Now, what about these two angles? What can you say about them? These two angles, you can consider this line AC as a transverse line. So these two angles, angle EAC and angle BCA, are alternate interior angles. And so, which means Y is equal to angle BCA, because they are alternate interior angles, that is equal to 45 degree. Right? And what about these two angles? Again, they are alternate. You can consider AB as a transverse line, and since AB can be considered as a transverse line and BC is parallel to DE, angle DAB and angle ABC, they are alternate interior angles, and hence we can say X is equal to angle ABC, because they are alternate interior angles, and hence it's equal to 65 degree. Now, what can you talk about angle BAC? What about angle BAC? Angle BAC. What about that? How much is that? Now you should understand that this whole angle is on one side of the line DE, and hence angle BAC plus angle X plus angle Y should be equal to 180 degree. You agree with me? And hence angle BAC plus 45 plus 65 is equal to 180. 45 plus 65 is 110, right? So angle BAC is equal to 180 minus 110, which is equal to 70 degrees. So that means this angle is 70 degree, right? So that is the other thing which you can derive, since you know angle X and angle Y. Is this clear? Any questions or any doubts? Please send me a mail on navayu.study@gmail.com, and I am there to help you. Alright, okay, fine. So now let us go ahead with the next problem. So I think this problem is clear, and how we can handle it is very clear, right? Now so let's look at the next problem. Now here there's another very interesting problem, question number 4, right? And so there's a line here like this, and this. Now this is ABC, and this is E, right? And this is D, right? And what is given as AB, line AB is parallel to CE, right? So it is parallel to CE, and there are some angles given. So angle 8, this is 80 degree, right? And what is this? This is 35 degree. That's given. And what is asked is what is angle ACE equal to how much? Angle ACB equal to how much? And what is angle ABC equal to how much? These are the questions. Right? Now, how will you do this? Now, you should understand one thing. These two are parallel lines. And I can consider this line BD to be a transverse line to both these lines AB and CE. And if that's the case, what can you say about angle ABC and angle ECD? What can you say about that? They are corresponding angles, right? Aren't they? They are corresponding angles, and if they are corresponding angles, that means angle ABC is equal to 35 degree, right? Angle ABC is equal to 35 degree. All right, and so if angle ABC is equal to 35 degree, right? So this is 35 degree. And then what? So that is given. So angle ABC is found. Now what about angle ACB? Angle ACB, right? Now how do you do that? Now, if you look at AC, can be also considered as another transverse line, which is cutting angle the lines AB and CE. And so in which case I can also say angle BAC. What can you say about angle BAC and angle ACE? If you consider the line AC as a transverse line to both these parallel lines, you can say they are also corresponding angles. They are corresponding angles, which basically means angle ACE is equal to, again, 80 degree. Perfect. Now, what can you talk about the sum of these angles? And sum of angle ADE ACE and ACB. Angle ECD plus angle ACE plus angle ACB. What can you say about the sum? This sum has to be 180 degree. Why? Because this is the total angle which is on one side of the line around a point is going to be 180 degree. And since these are adjacent angles on the same point, on the same side of the line, the sum should be 180 degree. Right? This is something we have already seen in lines and angles. So now what is ACD? ACD is 35 degree. What is ACE? ACE is 80 degree. That's what you found here, 80 degree, right? And plus angle ACB is equal to 180 degree. I can do transposition, and so I can say angle ACB is equal to 180 minus 115 degree, and that is equal to 65 degree, right? So angle ACB is 65 degree. So I've got angle ACB. Now what I have to find is angle ABC, angle ABC. Okay, so I think angle ABC is found. Now what is angle ACE? That is also found. So angle ACE is something that I have given here, right? So and ABC is this one. So all the angles which have been asked is found by using simple properties of transverse line with parallel lines, right? Okay, cool. Now let us look at another problem. So I probably may have to go to the next page, otherwise I will not get a continuity. Alright, so this is question number 5. Right? Now let us look at this particular question. So I have two parallel lines here like this. And then oops, where is this? I should at least make it look like a line. Okay, so let us look at the, so this is AB, right, and this is CD. So these are two parallel lines. So AB is parallel to CD, right? So that's given, and then these two angles are given, right? So this is angle 50 and this is angle 40. So this is angle 50 and this is angle 40. So that's also given, right? Now what is asked? What is asked is what is angle BOD? Angle BOD, what is it? That's a question. Now what I can do is, how can I solve this problem? What I can do is, I can just draw another parallel line like this. So this is O here, right? I can line another parallel line here. Let us call it as EF, right? So, and I say that EF is parallel to AB. And of course, if EF is parallel to AB, I can also say EF is parallel to CD, because AB and CD are parallel, right? So AF is parallel. So I am drawing a line which is parallel to one of these lines, which automatically makes it parallel to the other line, right? Because the AB and CD are parallel. So if that's the case, then what I can say, I can consider now OB as a transverse line which is cutting the two parallel lines EF and AB, which basically makes it, what will be the angle? What will be angle? What can you talk about angle BOF? Angle BOF is going to be let's talk about angle BOF and angle ABO. What are they? They are alternate interior angles. Alternate interior angles, aren't they? They are. right? They are alternating interior angles, and in which case we can say that angle BOF is equal to angle ABO, which basically means angle BOF is equal to 750 degree, right? Now similarly, let us look at these two angles. So angle CDO and angle FOD, right? So what about those two angles? Angle CDO and angle FOD. What are they? They are also alternate interior angles, aren't they? They are, right? They are alternate interior angles, and which basically means angle FOD is equal to angle CDO, and which means FOD is also 40 degree. And what does angle BOD? Angle BOD is equal to angle BOF plus angle FOD, which basically means it's 50 degree plus 40 degree, which is 90 degree. So the only thing which I had to do is I had to put this extra construction of a line which is parallel so that I can use alternate interior angles, right? So that's a thought which has to go in. So whenever you get a problem, you need to think, is there something else which I can do to use the principles which I have learned? So here I've added one line here. I drew one line which is parallel to these two lines, and that helped me to use alternate angles. If I didn't draw that, then of course I wouldn't have been able to do this. So think that these are also possibilities. It's not necessary that you have to just live with the diagram which is given. Probably we may add one parallel line or one perpendicular line or something to basically start using the principles that you learn and apply it to solve the problem. Alright, so here is one example where I've done that. Okay, now let us look at the next problem. So next is we have a quadrilateral, right? So we are given a quadrilateral. What is quadrilateral? Quadrilateral is nothing but a polygon with 4 sides, right? So rectangle, parallelogram, rhombus, square, they're all examples of quadrilateral, right? Okay, fine. So now I am actually given a quadrilateral like this. So let me name it as AB, CD, and what is given as AB is parallel to CD and AC is parallel to BD, right? So that's given. So AB is parallel to CD, that's given, and AAC is parallel to BD is also given. Alright, now this is what is given. Alright, now what basically is asked is prove that angle ADC is equal to angle ADC. Angle ADC equal to angle ABC. So what is asked is, now what is angle ADC? So let me just okay. And I need to erase all this. Extremely sorry for that mistake. Okay. Okay, fine. So, okay, let me erase this also. Okay. Alright, so angle ADC is equal to angle ABC. That's what you're doing, right? Angle ADC is equal to angle ABC. Now how can I do that? So if I say ADC is X, okay, now these two are parallel lines, and you can consider CD is a transverse line. So what can I talk about? What can I talk about ADC and angle DCB? What are they? They are consecutive interior angles. Right? They are consecutive interior angles. If you consider CD as a transverse and these two are parallel lines, then these two angles are consecutive interior angles. Right? And hence angle ADC plus angle DCB should be equal to 180 degree, which basically means angle DCB is equal to 180 minus X. Correct? 180 minus X. Alright. Now, what about assume if you consider CB as a transverse angle, a transverse line to these two parallel lines CD and AB, then what can you talk about angle DCB and angle ABC? They are again consecutive interior angles, and hence angle DCB plus angle ABC is equal to 180 degree. And what is DCB? DCB is 180 minus X plus angle ABC is equal to 180, which makes ABC equal to 180 minus 180 minus X, which gives is equal to X. So, which basically means angle ADC is equal to angle ABC. Extremely sorry for getting the problem wrong, and that made it a bit complicated, but this is all what it is, pretty simple and straightforward. So I just used the concept of consecutive interior angles, and then I figured out that these two angles are the same, right? Okay, fine. So that is actually this problem, pretty straightforward. Okay. Now let us look at the next problem, question number 7. So here again we have two parallel lines. Okay, so here we have CD and AB, okay, and this is given as 125 degree. This is X. This is Z. This is Y. Right? Now we need to find what all these angles are. Let's try to find all these angles inside this quadrilateral. That will be easier, right? Now, what is X? Pretty straightforward. Why? Because these are supplementary angles, right? And what is given as AB is parallel to CD, right? So that is given, right? Now, what is X? 125 plus X will be equal to 180, and so X will be equal to 55 degree, right? So X is already known. Now, since if let us consider this line CE to be a transverse transversal line intersecting CD and AB. So what can you talk about angle BAC and angle ACD. They are consecutive interior angles, aren't they? They are consecutive interior angles, and since they are consecutive interior angles, you should say that angle BAC plus angle ACD is equal to 180 degree, aren't they? Yes, definitely, right? And what is angle ABC? Angle ABC is nothing but what is angle BAC? BAC is nothing but x. X is equal to 55. So 55 plus angle ACD is equal to 180, and so angle ACD is equal to 125 degree. Right? Perfect. Now, what can you talk about? Now, it's also given that this is x. Okay, it's also given that this is x. So, which basically means angle ABD is equal to x, which is equal to 55 degree. And if that is known, if you consider BD as a transverse line to AB and CD, then what can you talk about these two angles? Angle ABD, angle ABD and angle CD, vacuum magic, CDB. What can you talk about these two angles? They are again consecutive interior angles, right? And which basically means angle ABD plus angle CDB is equal to 180 degree. And since angle ABD is 55 degree, which is given in the problem, through the x and x being same, CDB is equal to 180. So angle CDB is equal to 180 minus 55, which will be 125 degree. So we got all the angles. So we found the value of x, found the value of z, and we have also found the value of y. All the angles. Pretty straightforward. Again, using consecutive interior angles, rule of consecutive interior angles. And sum should be 180 degree. So I think these are some very good examples. I hope that you got a very good idea of how we can use all these principles. I want you to go through more problems, and even this, what you do is please redo the problems, rewind the video just to show the question, and then try to do the steps as I did and try to understand it well, and then try to do more problems. If you are finding any difficulty, or if you have any specific questions, please to send a mail to the following email ID. You can ask your parents to do that if you cannot. Navayug.study. You can send a mail to navayug.study@gmail.com. Alright? Okay, see you for the next session soon. Have fun with math. navayug.study@gmail.com. Cool.